Welcome to a new test and teardown video. This time it's something really weird and different. So this is a Capintec incorporated model CRC-120R ion chamber. So it's a radioisotopic calibrator. Using a ion chamber technology. I only got the ion chamber and it is scheduled for recycling, so I am supposed to take this apart and throw it out and recycle all the metals and materials. So that is just how it is going to be, but they let me show you what is inside, so that is what we're gonna do and get at least a little bit of entertainment out of this. So it is very heavy, 15.5 kilos. The diameter here is 17 centimeters. It is 42 centimeters high. The hole is 7 centimeters and the hole is 27 deep, 27 centimeters, as you can see here. And yeah, I don't have this little lid that you're supposed to close the hole with when you put in radioactive samples. And the idea is you have, of course, a measurement station you connect to this cable, and then it count all the pulses and control the different relays in the detector and voltage generator system. And then it counts the pulses, and this way figure out the different radioactive sources and how much it is and all those kind of things. I think I should put in a link to a very good page that will show you how you can count the different pulses and this way figure out the content of your radioactive sources, just so I don't need to repeat everything here. So I think what we should do is we should try and open this thing. The idea is not to open it here from the top. I already tried that, but this is obviously impossible because this locking mechanism here, they also put in some the paint goes all the way in here, and I really cannot pull these in like this. I don't have tools that is strong enough to do that. So we need to open it from the bottom. But you can see here, this is aluminium, and I believe this is like 4 or 5 millimeter thick. Then we got about 2 to 3 millimeters of lead. This is lead, and then aluminium again. So the container is aluminium, so that means it's a gamma. I believe this is a mostly sensitive to gamma radiation. Ooh, that was some heavy duty stuff. So here at the bottom, the idea is first you unscrew this little lid here in the middle, and then you get access to a little screw here. I did not know that was the idea, so I just pulled it apart and then I cut this little connection to this detector. Well, let's try and unscrew everything once again so you can see what is inside. I think this white powder, I think this is because of the aluminium is completely corroded. I believe this one was stored outside in the rain for many years, and all this corroded aluminium just goes down here at the bottom and then pours out the hole in the middle like that. I mean, it's not smelling or anything like that. I try to wash it a little bit here so I don't get completely dirty or anything like that. But now we can have a little look what is going on inside here. So there is a circuit board covering half of this space. And this here is this little wire I mentioned that I had to cut. This one is connected to the detector. And I believe this connection here goes inside somehow into the little chamber. Obviously it's probably, oh sorry, it's a little bit out of focus. So it's marked positive. So there's a supply voltage that goes to this one, and this is the detector, and down here is a guard ring, and then you have the rest is just ground, shield, everything like that. Inside this little shielded box, I find, in the beginning I had the idea that it could be a transformer, but it's only a coil, because this wire here is connected to this, the outer chassis of it, and then we got those two wires that comes out of the inductor, and those the black one goes again just to the chassis of it. And then here's the funny thing, all those red units you see here, that's actually a reed relay. We got two little wires in the middle. This is the reverse diode for the coil, the activation coil, and in here you have the contact. This is either a special shield or a center tap to the relay. The fun thing is this wire here is not connected to any of these, so I'm not super sure if it is a shield or if it's a tap or anything. There's a little Teflon isolation here as well, so this confuses me a little bit. The two screws here connects this area to that part of the relay. At the beginning I had the idea these could go down and connect to the frame or to the chassis, but that is not the case. And then yeah, those two little wires you see here, they go underneath and they come up here. So those two wires are the activate wires for the relay. We got two more relays here, and they are also controlled, I think, by individual signals, because you have individual 3 running diodes. So that's a little bit special. It's all controlled by this multi-cable to drive the 3 relays. So I believe it goes like it's shorts everything, and then it measures, shorts and measures back and forward. So you have a relative and a zero measurement, right? This will be the detector input, and you see all the resistors, they are really, really high value. So this is 2000 mega ohms or something like that, right? And this is the same resistor down here, and we got some other resistors, and on top of all this we got some capacitors, and this tells me they're trying to speed up some of the signaling here. You see, why else would you connect capacitors in parallel with those? And those Styroflex capacitors here, they're really, really good for super low leakage. So that's why they're using these type of capacitors. And under the circuit board we have this blue box. I believe this is the amplifier module. There's a little marking right there. I don't know yet what is going on. I should probably unscrew this circuit board and investigate a little bit deeper here what is going on. So that is a little bit surprising. So this amplifier module is from Analog Devices. Maybe there's a number or something underneath this plastic tape or something. So here's the module, the Analog Devices 310J, made in USA. So this is a very, very special op-amp module. Looking at the datasheet, it was super easy to Google the datasheet. It says something about it's a Varactor Bridge operational amplifier. I think today you would call them chopper stabilized op-amps. But in old days they use Varactor capacitor diodes. And this one got insanely low bias current and a low voltage drift. And it's of course made for the most amazing things. I will show a few pages from the datasheet so we can see its open loop gain. We can see its frequency response, 2 Hertz, full power response, only 2 Hertz. So of course it's super slow. And what else can we see? Input impedance is just crazy high, and supply voltage plus minus 15, and it can work from 12 to 18. And what else did I see? In the schematic I find some very nice drawings about how they suggest to make the circuits using flying components into Teflon fittings and all that, exactly like this design is made. They also show what is inside this op-amp, how it is designed using voltage controlled capacitors or Varactor diodes. 4 of these in a bridge, and they use a 250 kilohertz carrier oscillator. So there is of course an amplifier that is modulated and then DC gained, and then the feedback voltage, just like an op-amp. You can go back to the inputs again and all that. So super fascinating. I did a little more Google search around you for this interesting analog devices, this 310J. I find this eBay ad here, or eBay, they say $7,000 for 1 unit, and it has been desoldered and everything. That is a little bit interesting, isn't it? I can also find one on another side. I think this is a used one. Yeah, I definitely used, this is a used one, but they call it re-certified. So it is guaranteed to be working, and it's $381. I hope it is completely sealed, so it's not destroyed by this white rust. I think I will carefully try and see if I can desolder this and try and boot it up and see if I can get it up and running. What have they done here? It's, yeah, unfortunately it's soldered to the circuit board. It looks a little bit like we got some 2 screws here, so it could have been in some socket. So let's try and remove the other circuit board here. Ooh, it's really, really badly corroded. I think it's quite funny, those 2 screws like that. There isn't any electrical connection down to this LED. I think it's supposed to be a connection, right? Let's take the screws out and have a little look. See? Definitely it was supposed to be a connection, right? But I tested this before I took anything apart. It's just standoffs. That is weird. This little part down there is also very weird. This little part down there, I don't understand what that is doing. And why is this guard connected to this one, and then this one is, I think, as you can see here, there's a little isolation between this and that one. And there's probably a thin wire going in here. Also, this part here, what exactly is going on right there? So this looks like we got some kind of a gas or vacuum in the ion chamber. And I talked to an expert about this, and he talks about special gases that will give it higher sensitivity or better detection for some special types of radiation signals. I mean, is this really true? That means I'm a little bit skeptical about opening this one. At least I don't want to do it indoor. But, I mean, I need to pull this completely apart. And also it looks like it's going to be very, very difficult to release this lock. You can see how bent this is. So there's probably a ton of pressure here somehow. And what about those screws? What are they doing? And I don't know yet if I can come any further as it is right now. I don't have any tools that will fit right there. So it is getting more and more funny. See, that was set screws, and then oh, you gotta love this story here. So when I took out the set screws, suddenly the whole thing went kaboing. So something down here can move, and it's probably some. Can you hear? Huh? Oh, look at that. So when I push, now this part down here is moving. Look at that again. What exactly is going on in here? This is getting, yeah, really weird. And I got a big shock. Oh, that was so funny. I still don't get it. Let me see if I can put my ohm meter where we can see this, okay? I don't know if I'm able to do that, but this is the outer chassis. And if I put in, see, we have a good connection to the chassis, okay? Wouldn't you think? Here's the point where this part of the circuit board is connected was screwed down, right? We got mega ohms. I mean, how is that? I mean, so is this isolated on purpose? Mega ohms. This is just so weird. Okay, so this is also 1.2 mega ohms. So all this is completely isolated. Yes, of course, this stuff here is. So all this is, of course, isolated from the chassis, right? Okay, so this is, so there's a zero connection between these two. So this is just, so there's not a little isolation thing up there. So we got 0 ohm here and here. This is a little bit weird because why? That I did not expect. And then, okay, good. So here, so then this is the detector. So why is this part, this black wire here, That was also supposed to be the detector, right? I had the idea this was the outer shield, and then this part here is the detector. So this outer shield is connected to the transformer. This part is isolated, and then there's a little thin wire or something inside this. So these two things that are not connected directly together. I need to see if I can make a schematic or somehow figure this out. I don't understand exactly what is inside this box. Looks like an inductor, right? So there's something really weird going on here. I think this is a battery or a capacitor or something like that. It looks also actually like a battery, but it's only 120 millivolts, depending on how I connect to it. So what is in this? Aha, so that is all the white stuff. That is leakage from this battery. So yeah, definitely was a battery. So this is a high voltage lithium battery, 150 volts. And they come with all sorts of warning disclaimers and whatnot. Look at that, we can see all the different cells in here. And it was nicely packed in here. And I think the idea is you are able to change the battery, or it was changed, or something like that. Here says something, and then 94. So it's quite a lot of years ago, but that is how it works. I want to try and make a tiny little schematic that explains how I think this is all connected. I really haven't yet figured out this little wire that goes into the center of the relay. I want to see if I can explain exactly what is going on here. So now the relay is energized. This is my ohm meter that shows we have a short circuit right there. So this negative point here is not connected to anything like that here. This little wire we have that it goes into the relay. I still haven't yet figured that out. I need to pull apart the relay. So here's only 4 volt and 25 milliamps. Click. And then it's disconnected again. So it's probably pulsing the signal once every second or something like that. So here we go. I pulled out the relay. Oh, you can really see this. So what is going on with this? So there's a wire that just goes around there for no particular reason. It's just trying to shield somehow. I don't understand why this is a shield. This wire just goes around the glass like that. That is the weirdest. So they're trying to remove any kind of leakage from this pin to go around the glass and hit the detector pin. It will now, this leakage will be stopped at this point and be transferred to ground instead of going into the resistor of 2000 mega ohms. How about that? So I made a little paper cat about what is going on here, and I think you probably get what I try to explain here. So we got this outer casing and this is chassis ground. We got two other parts of the detector, and one part is always connected directly to the battery, and the other part, the inner part here, is also always connected to the battery. So there's always a voltage potential between these. How about that? So when you power this up, when you want to do your measurements, the positive is then connected to chassis using a relay. And this input here goes to the amplifier board. On the amplifier board, we got some different resistors. We also got some different relays. Again, two additional relays in series with this system. Here we got some trimmers actually in series with all three. But the main point is we got three different gain ranges. The highest is always like this, and then you connect this or that one instead or in parallel, right? And this is how it is done here. We got those trimmers right here, and this one is the permanent on, or the always selected, goes here. And there we have it, different capacitors on top of the different resistors. So this is the 200 mega ohm, and this is the 20,000 mega ohm. And here is 2 mega ohm. You connect, or you select these using the relays. I also added a little bit of text here, the positive supply, ground negative supply. This is the output, and this is the balance. And balance just goes to one of the pins here, and these are connected together there. This is a DC feed point and all that kind of stuff. Not super interesting to this. I didn't draw all those details on the principal diagram here because don't need to be that super detailed. But I think I want to try and remove the module because this board here is completely full of corrosion also under the connector like that. So I can't play with this module as long as it is on this board. And I really want to see if this module is working. That could be fun. Yeah, see here it is. This is a little bit more of an explainer of what is going on. So that was the balance signal, power supply, a positive common, a positive for the relays. And that will be the three different signals for the relays. I was able to desolder this thing, this beautiful module. It is, of course, super corroded like that. I hope this didn't go inside. And look at that. So the input pin, that was a connector. Maybe I can unscrew these and see if there's probably a nice rubber gasket or something. So now I am inside this module, and you see the corrosion is really bad here on the outside, but it didn't really go that much inside the module. So that's a little bit of luck. I think I see it a little bit here on the circuit boards. So I think I will try and clean it as much as I can, and then I will try and assemble it and test it. Should probably see if I can get this out of this metal here so I can clean it. So let's look a little bit more inside the module. I cleaned it really nice and fine. Look how nice and shiny it is now. I used toothpaste and an old toothbrush to clean this, and burning hot water and compressed air. And now it is really nice and shiny. And all the nasty corrosion from the battery pack is completely gone. I don't want to go and touch it actually. I only want to touch the edges here because of this is a very, very high impedance product, and I probably want to use it for something like that. So that will be the 2 input, or I think it's a double Varactor diode kind of system. And that will be the 250 kilohertz oscillator system. And then the output stage buffer. So there's a capacitor here that goes into those diodes or something like that. I don't know exactly what is going on here, but I think it's fascinating. We can see inside a little op amp like that. I should probably put in a little zoom picture of this this output stage amplifier. That is really sad. After all this work and cleaning and fixing and I don't know what, well, this amp doesn't work. So I even added a trim. I'm using plus minus 12 volt. And I'm of course using those nice resistors, and we got some input signal, we got the scope on the output, and it's just not working at all. And I'm putting in a sine wave, a 1 hertz sine wave, and I just get an output that is full rail, and it's not pulling any current, the negative rail. So, yeah, just bad luck, isn't it? And my output is just fully positive. Nah. Maybe another day. But so far, it's not working. I tried, of course, to bypass those resistors just to see if these are not working or if the impedance is too high and all that. Still no luck. I wanted to play a little bit with the components. I mean, those resistors here, they're really, really cool. So 20,000 mega ohms, right? But there's also a, what is this, 200 mega ohm resistors. And it turns out that all these really high value components, I mean, maybe this meter here goes a little bit higher. This is 1 giga ohm as the highest. And my other meter goes only to 100 mega ohms, the highest. So that means I do not have equipment to measure those 2 resistors. What does this mean? I need some more equipment. Let's play a little bit with the batteries before we throw these out, so you can easily see. Oh yeah, this is totally corroded. So they more or less fell apart, and I think, see, 7 volts for this one, 9 volts. Oh, a little bit more. And what, 39 volts for this one. So quite funny. Oh, they're made of CR-120R 32s. How cool is that, Senyo? How many? So let's just open one of them, right? Oh, I did not expect that. So there's a, oh, look at that. They interconnected them. Really, really nice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. So it's 48 cells in total, right? That is pretty neat. I am happy to announce that I was, of course, able to get this out. I mean, this is probably the toughest lock ring I've ever pulled out. It is probably more than 3 millimeters thick. And look at the dimensions here. It's just insanely tough to pull out. I don't know if you can guess how I was able to pull this out, but it did involve some sort of nasty tricks, and a screw that went over here, and some of this, some of that, some of this, all this, and some big screwdrivers, and some of this, and that was tough stuff. Well, I think I now know why we didn't have an electrical connection between this plate and the rest of the stuff. It's just because of corrosion. Corrosion goes in and then it lifts everything apart, and it was of course supposed to be nicely electrically grounded, but this lithium battery just corroded everything. This is a plate of lead. This is aluminium, and here's another piece of aluminium. This is the one that holds the ion chamber. See, also completely corroded. And see down there, and there's also aluminium and lead. There's a lead plate there as well. It is really, really a beautiful chamber here. And now we know the age of the test chamber, 8884. That's a nice date. And we got a little bit of information here. Let's see if I can get this. 180 PSI. Something about pressure. Is there anybody who can figure out what kind of gas this one contains? I don't know yet, but I definitely don't want this one to blow up in my face. And this is of course the gas filling, pressure filling and all that. I don't know why this looks so weird right there. And the corrosion also went all the way in here. Really, really bad. But that is the super nice test chamber. And I think I will just end this video right now. It's already way too long, okay? So thank you very much for watching. I hope you had a little bit of fun. At least I was definitely entertained here for a couple of days. So see you around. Bye bye.